Get ready to explore dark energy, the key to the fate of the cosmos. Hello.
Hello.
This is Science Zero. Our topic is pretty breathtaking, the fate of the universe.
Just look at that sky, so full of stars.
The universe began 13.7 billion years ago with the Big Bang. It's said that the universe contains hundreds of billions of galaxies.
Beautiful.
Galaxies come in many shapes and colors. They are collections of stars, some forming spirals, and others, like this one, rather look like hats.
They're lovely.
And sometimes we even see galaxies colliding with one another. The variety of galaxies is truly endless.
You could spend hours looking at the stars.
Yes, but scientists are now saying that these beautiful galaxies that we see won't last forever. In the distant future, all of the galaxies could vanish. Now, the key to this fate is called dark energy. And it's the hottest topic in cosmology today.
It's called dark because we don't really know what it is. And this dark energy, whatever it is going to wipe out the galaxies. I can't wait to hear the story.
The discovery of dark energy changed our fundamental understanding of cosmology.
Johns Hopkins University in the United States. The existence of dark energy was proposed by American astronomer Adam Rees. Rees was then a young researcher just out of graduate school. His research addressed the speed of the universe's expansion after the Big Bang. The universe has been expanding since the Big Bang. Cosmologists long believed that the rate of expansion has been slowing due to the gravity of the matter, such as galaxies in the universe. Rees was investigating the extent to which the expansion was slowing. So he compared the speed at which nearby and distant galaxies are moving away from us. Nearby galaxies are from a more recent era in the history of the universe. Distant galaxies, an older era. The rate of expansion in those eras can be compared. The universe's rate of expansion had been accurately measured as far back as 5 billion years. Rees made new measurements. He calculated the rate of expansion of the universe 7.6 billion years ago and compared the two. The results were astonishing. The expansion of the universe wasn't slowing down, it was accelerating.
Initially I thought, oh, I must have made a mistake. I'm sure I made a mistake. This is too weird, and this can't be right.
Rees rechecked his calculations and measurements over and over to ensure no errors had crept in. He could find none. The expansion of the universe was accelerating.
It was very surprising and quite exciting that I was in the process of doing the actual measurement and analysis of how much was the universe slowing down, and the answer we saw was really surprising because it was the opposite. So not only was the universe not slowing down a little bit, it actually appeared to be speeding up.
Rees published a paper with his results in 1998. It caused a sensation. An accelerating universe. This bold hypothesis overthrew existing theories. Previously, there were two models of the expanding universe. One model asserted that gravitational interactions would gradually slow the expansion. Another model said that the universe would contract and ultimately collapse. But Rees discovered an entirely new model, one in which the universe would suddenly accelerate its expansion at a certain point in time.
I was afraid this is the last paper I'll publish, because when people see that it's so wrong, I'll be famous for being wrong.
Rees's paper struck the scientific world like a thunderbolt. But later, as researchers published more and more results that backed his claims, the theory of an accelerating expansion of the universe became unassailable. What is the prime mover behind the expansion of the cosmos? Researchers surmised that it had to be some form of energy opposing gravity that was pulling things apart. They called it dark energy. Since then, dark energy has been reckoned as the power that holds the fate of the universe.
So the expansion is accelerating. That sounds scary somehow. The cosmos is doing something really surprising.
People often talk about the expanding universe. It's astonishing to hear it's accelerating. And the fact that there is some unknown energy behind it is a real puzzle.
Yes. Now, let's welcome an expert to help us explore what this mysterious dark energy is all about.
Yes, a professor and cosmologist from Nagoya University, Naoshi Sugiyama. Sugiyama-san, what was your first reaction to the idea that the universe's expansion is accelerating?
Well, partly I felt that this was a tremendous discovery. At the same time, I had my doubts that the universe could really be accelerating so fast. It was flabbergasting. But later on, as more observational data became available and the evidence grew more and more conclusive, not accepting the discovery became impossible.
So what is it that makes dark energy such a tremendous discovery?
Oh, well, it's a tremendous discovery because it could radically alter humanity's view of the cosmos. 400 years ago, in the time of Galileo, the view of the cosmos shifted from geocentric to heliocentric. In the 20th century, the Big Bang theory resulted in the new view of an expanding universe. This discovery could cause an equally important shift in how we view the cosmos.
To say that it's a big enough discovery to rival those two watershed events in cosmology really drives home how important the discovery is. It affects everyone around the world.
Yes, within the current framework of cosmology, looking at the history of the expansion of the universe, without this idea, we can't truly understand the cosmos. That makes it an important part of the puzzle that scientists are working hard to explain.
So dark energy is shrouded in mystery. Now, to help us visualize it, we'll ask you to do an experiment, Yasu-san. Now, would you open your hand, please?
My hand? Sure. Oh, an apple.
That's right. Now, would you please toss that apple into the air?
Okay, here I go. It drops back down, of course.
As we all know, the apple falls because it is pulled by the Earth's gravity.
Now, what happens if dark energy takes over? Yasu-san, would you please toss the apple again for us?
Okay. Oh, where's it going?
Up into the sky.
In real life, that couldn't happen on Earth, of course. But if dark energy were billions of times stronger than it is today, it would overcome the Earth's gravity and the apple would actually fly away.
And not just apples, so would we.
Yes, if the dark energy was strong enough, that is possible.
What a strange kind of energy.
It sounds like a repulsive force, like, for example, between magnets. But this is slightly different, right?
Yes, repulsive forces usually become stronger as the distance grows smaller. But the repulsive force of dark energy pushes apart more strongly at greater distances. In that sense, it is a repulsive force that opposes gravity. You could call it an anti-gravitational force.
Though much about dark energy remains unknown, a Japanese researcher has announced some astounding findings. In June 2010, an international physics seminar was held at Kyoto University. Eiichiro Komatsu of the University of Texas researches dark energy. Komatsu-san used a space probe called WMAP to make fine-grained observations of very faint radio waves coming from the edge of the universe. Here is the distribution across the entire sky. The red and yellow areas show where radio waves are strongest, and blue shows where they are most faint. Analyzing this distribution allowed Komatsu-san to derive the amount of dark energy in the universe. In 2009, Komatsu-san published a paper on the result of his research, indicating that dark energy makes up 72.6% of the entire universe. Over the next 12 months, Komatsu-san's paper was the most cited scientific paper in the natural sciences.
We know that dark energy exists. Now we just need to figure out what it is.